Hello YouTube, welcome to the class again. In the last class we have discussed about types of chemical reaction, and before that we also discussed about how to balance a chemical reaction. So in today's topic we are going to cover endothermic process, exothermic process, types of single displacement or double displacement reaction, redox reaction, hardly within 15 to 20 minutes. So stay tuned and have a enjoyable class. So starting with endothermic process and exothermic process, and let me tell you, a process where heat is absorbed or gained during the reaction, that is called endothermic process. For example, melting of solid by supplying heat is an endothermic process. I hope this is clear. If you take a piece of ice cube and after some times it becomes water, that means this particular ice cube has absorbed the heat from the surroundings. So that's why it is an endothermic process. I hope this is clear. Now coming to exothermic process. A process where heat is released during the reaction, that is called exothermic process. Heat is released means it could be in the form of gas, energy or light. Now example goes, freezing of a liquid at its freezing point is an exothermic process. If you are going to freeze something at that particular freezing point, that is also exothermic process. So far you have understood about the endothermic and exothermic process, but let me tell you one of the most common example and common difference between endothermic and exothermic. We have already discussed about combination reaction and decomposition reaction. So our combination reaction by nature is exothermic and decomposition by nature basically endothermic. So that's why combination is opposite to decomposition and exothermic is opposite to endothermic. Now coming to the next topic, displacement reaction, highly essential, and for this particular reaction you have to remember the reactivity series. Reactivity series means what? It's a series of elements or series of metals where we can classify the metals according to their reactiveness. That means which metal is high reactive and which metal is less reactive. So if you want this reactivity series, I will make another video. Clear? Okay. So without wasting any time, let's go for the displacement reaction. It is a chemical process where a more reactive element replaces a less reactive element. I repeat, it is a particular reaction where a more reactive element replaces a less reactive element. That means I am taking A, B and C. Let's say A is a metal, C is a metal, but C is alone and A is with B. Now if I am taking the comparison between A and C, if C is more powerful than A, then C has the more ability to make the bond with B as compared to A. That means this B will comes to the C. It becomes CB, then who will be alone? The A will be alone. So in this particular reaction, you are going to see one is your single and one is your double. That means one is your element form, another one will be your compound form. This particular reaction when occurs, that's said to be single displacement reaction. I hope this is clear. This is called single displacement reaction. And it is fundamentally redox reaction. Remember that redox reaction we are going to study just soon after. Clear? Redox reaction means actually your reduction and ox means your oxidation. So it works according to reactivity series as I already mentioned. So to do so this kind of reaction you have to remember the reactivity series. Now some couple of examples I have brought for you. Let's see how we can see that. I have taken iron in the solid state, it's a metal, along with copper sulfate which is aqueous, that is blue in color. Since copper is less reactive than iron, so our iron is more reactive than copper. So iron has the chance or the ability to take the sulfate. It becomes iron sulfate, becomes FeSO4 in the aqueous solution. Then copper will be separated out. I hope this is clear. Similarly, zinc plus copper sulfate. So zinc is more reactive than copper. It gives rise to zinc sulfate plus copper. Another one, copper plus silver nitrate. So it gives rise to copper nitrate plus silver. Last step again, balancing. because the earlier cases was already balanced, so this reaction you need to balance. 2 nitrate, 2 nitrate, because here it is 2 nitrate, 2 nitrate, here it is also 2 nitrate. 2 silver, here it is also 2 silver. 1 copper, 1 copper. Another example, aluminum plus iron oxide or ferric oxide, it gives rise to aluminum oxide, that is Al2O3 plus iron. Last step again balancing, 2 iron, 3 oxygen, okay, 2 aluminum, 2 aluminum. And particularly this reaction, the last reaction, this is your thermite reaction. Sir, why thermite reaction? Because it is used in the industrial application and it is also exothermic by nature. I am repeating. Which nature? Exothermic. Usually single displacement reactions are exothermic by nature. I hope this part is over. Now coming to double displacement reaction. A chemical reaction where two ionic compounds in aqueous solution exchange ions. What they will do? Exchange ions. Let's say A is with B, C is with D. So what just happened? A takes over to D and C takes over to B. So new compounds will be formed, that is AD and CB. This kind of reaction will occur, that is called double displacement reaction. And for this particular reaction there is no need to obey the reactivity series, since both metals have the chances to exchange each other's ions. It is category basically two types. That means two types of double displacement reactions are there. One is your precipitation reaction, another one is neutralization reaction. So without wasting any time, let's go to precipitation reaction. So during a double displacement reaction, one of the products is an insoluble solid. That means if you take AB and CD gives rise to AD and CB. So between this AB and CD, if either one of the product is insoluble, then this double displacement reaction can be called as precipitation reaction. I hope this is clear. So for this I have taken some examples. Let's go through this. Potassium bromide, silver nitrate. So potassium is a metal, silver is a metal. If they are alone, either one, then we have to follow the reactivity series. But potassium is with bromine, silver is with nitrate, so they will simply exchange each other's ion. So the nitrate part will goes to potassium part and the bromine part is goes to silver part. So it will form potassium nitrate plus silver bromide. So between these two products, silver bromide is your precipitate. So simply in the bracket you need to write PPT. Instead of a PPT, in some books it is written that downward arrow mark. That means this symbol symbolizes to us precipitate has been occurred. And this product KNO3, this is your aqueous solution, means it is soluble in water. I hope this is clear. Another example, sodium sulfate plus strontium chloride. It gives rise to strontium sulfate, which is your precipitate, and sodium chloride. This is your aqueous, because sodium chloride is an aqueous solution or soluble in water. I hope this is clear. This example I hope you can do, otherwise let me do in the comment section. Clear? Next, neutralization reaction. This is the second category of double displacement reaction. Neutralization reaction means the same pattern it will be followed, but we have to take an acid and a base. Whenever an acid takes over a base or base takes over an acid, they forms salt and water. This kind of reaction is called as double displacement, so as neutralization reaction. So I have taken one example. Let's understand. HCl gives rise to H plus ion, NaOH gives rise to OH minus ion. So the remaining part will be Na and Cl, sodium chloride, that is your salt, NaCl. So whenever hydrogen and this OH means I am writing here hydroxide. What's called? Hydroxide. Whenever these two will combine together, they forms the water. And usually, dear student, these reactions are exothermic by nature. So simply you need to write heat. Last step, I think it is already balanced, so no need to balance it. I hope the neutralization reaction part is over. Now the most important segment of neutralization reaction is types of neutralization. That means if you are taking an acid but it is strong acid, if you are taking a base but it is strong base, that means strong acid plus strong base, neutral salt will be there, and the salt nature will be neutral, and the pH value will be 7. Sir, what is the meaning of pH? It's a kind of indicator through which you are going to understand whether a substance is acidic or basic. Second one, strong acid, weak base. The nature of the salt is acidic by nature. The nature of the salt is acidic by nature. That means if you talk about anything strong, depends on that particular acidic or basic, the salt will be obtained. I have taken weak acid, strong base, it is basic in nature. Weak acid, weak base, both are weak, so that's why that is neutral. I hope this is clear. Now coming to examples in daily life. If it is indigestion, then we are taking antacid. It's a kind of medicine, or we can say simply magnesium hydroxide. Okay, if it is excessive acidity, then we can take antacid for the neutralization. If any bee sting injects in your body, then we are applying baking soda. Which soda? Baking soda, to just get the relief. And for the soil treatment, we are using lime. Lime means actually calcium oxide, and the nature of this particular lime is basic. That means if the soil is acidity or too acidic in nature, then we are using lime. I hope this is clear. Now coming to the most important segment, and this is the last part of this particular topic, that is oxidation and reduction. Okay, very easy concept, remember that. But initially I am telling you, if there is oxidation, there must be reduction. If there is no oxidation, there will be no reduction. Okay, oxidation means what? Gaining of oxygen, otherwise loss of hydrogen, otherwise loss of electron. Reduction means gaining of hydrogen, loss of oxygen, or gaining of electron. Exact opposite will be there. That means during any chemical reaction, for example, magnesium plus oxygen gives rise to magnesium oxide. Last step, balancing, done. Looks to be which type of reaction? Combination reaction. But my question is basically, is it a redox reaction, or is it a oxidation reaction, or is it reduction reaction? To be honest, this combination reaction is classified as redox reaction. Sir, how basically possible? If during the reaction oxygen is gained, who has gained the oxygen? This magnesium. So magnesium is getting oxidized. Oxidation means oxidized. If a magnesium is getting oxidized, so oxygen must be reduced. Oxygen must be reduced. I hope this is clear. And dear student, surprisingly, oxidized means the substance will be your reducing agent. Reducing agent. If anything is getting reduced, that will be your oxidizing agent. Mostly the students are getting confused about this particular segment. Which substance is getting oxidized? They are actually remembering that is the oxidizing agent. No, which substance is getting oxidized? That is your reducing agent. Which is getting reduced? That is your oxidizing agent. In short, overally, all these possible four answer, whether it's oxidized, reduced, reducing agent, oxidizing agent, they must lie in the reactant side. Which side? Reactant side. I hope this is clear. It is a combination reaction, no doubt, but it can be a redox reaction. There must be a question, sir, is there any type of reaction that we can say redox reaction? Yes, like single displacement reaction. I am taking one example, you will easily understand. Like zinc plus HCl gives rise to zinc chloride plus H2. Zinc chloride plus H2. Clear about this point? So if zinc forms zinc chloride plus H2 with HCl, then what must be oxidized and what must be reduced? Now clearly see that zinc is a metal, but in the other side zinc is actually a salt, that is zinc chloride. I hope this is clear. So zinc and chlorine, the formula must be prepared by valency. So zinc valency +2, chlorine valency 1 minus or -1. If I am talking about zinc +2, that means electron must loss, minus means electron must gain. I hope this is clear. If you talk about electron is lost, that is called oxidation. If you talk about electron is gain, that is called reduction. So can I say that zinc is your oxidized and hydrochloric acid is your reduced? I hope this is clear. Clear about this point? This particular segment you need to understand. And whenever reaction occurring oxidation and reduction, that is called redox reaction. Oxidizing agent means what? The substance that gains electron gets reduced, helps to oxidize another substance. As I said, oxidizing agent means it must be your reduced, and reducing agent means it should be your oxidized. Already I have explained. I have taken one of the example, magnesium plus oxygen gives rise to magnesium oxide, and for your understanding I have taken copper plus oxygen gives rise to copper oxide. And after completion of this balancing part, let me know in the comment section, copper is getting oxidized or reduced, oxygen is getting oxidized or reduced, and between these two, which one is your oxidizing agent and which one is your reducing agent. I hope this is clear. Understood? This reaction and this reaction, try it by yourself. If not, let me know in the comment section. And this is the real life applications of the redox reaction. So what? Whether you are talking about roasting of iron, that is also a redox reaction. Whether you are talking about oxidation of fats, oils, that is also your oxidation reaction or redox reaction. If you are talking about burning of any substance also, because for burning, which gas essential? Oxygen. That is also one of the redox reaction. So that's all about today's class, because corrosion and density, it's not in the current syllabus right now. I hope this is clear. And so far we have discussed about types of chemical reaction and their separation techniques. I hope this is clear to everybody. Okay, and of course thank you for everyone to make it successful. And we have completed the first chapter, and make sure to check the part 1 and part 2. There the links are in the comment section or the description part, and do not skip them or your concepts might just do a disappearance reaction. Clear? So and get ready for the next stop is a power packed one shot of the entire chapter, followed by a mind map. We are going to complete in the next couple of sessions. If this video actually helped to you, then hit a like, subscribe and share it with your friends. Okay, so thank you, stay tuned and have a good time.